here we go. Let's start speaking about Danfoss solutions for solenoid valves, or also where do we use solenoid valves? Okay, we will go briefly through legislation, what's cooking around, how solenoid valve is working, how do we design systems, product overview, installation, and etc. One of the hot topics, we may say so, is water leak. And actually, it wouldn't be an issue at all for somebody except insurance companies who are having some issues with that. Particularly in Scandinavia, we may say so, we have one damage every minute. So as we speak, we will speak today about 1 hour. We will have around 60 water leaks in Scandinavia. So 60 properties will have an issues around. Yep, and that cost to someone quite some money. In Germany, they do have almost 2 damages every minute. So in Germany, there will be about 120 issues as we will speak. That costs some money. So insurance companies are very busy with that. And in generally, they say that in average, all homes are affected by water damage every 25 years. So all of us who are now in the communication will probably have an issue with water leak. I remember myself, I had an issue when something was wrong with my, I would say, sewage probably, or maybe some water pipes. So when I was living in multi-flat building, our neighbors came from the ones from below us. They told that something is wrong. They have a wet ceiling. So we were trying to discover where issues could be. And in some cases, it's quite normal when your toilet hose is breaking. So that is probably the weakest link in the installation. Another topic, asthma, health issues. After only a day, mold begins to grow due to the high humidity. So that's an issue again to your health. And these data were taken from Research Institute. As for the heating side, we can say so that at least in Lithuania, it was noticed that plumbing or heating system issues are normally appearing during a heating startup. That's mainly late autumn. So, what do? We deliver to the market benefits. We are helping to prevent asthma. People should not leave the houses when we are providing them security from the leakages. And of course, insurance companies can review insurance fee if you have leakage protection. So what had happened in neighboring countries, Norway started 10 years ago. Then Denmark appeared with Danish building regulations, and Sweden is now expected to come around with regulations that leak protection in water works should be carried on. So we have some businesses. How do we save our properties around? One stuff on the left-hand side is to put a sensor in the so-called wet rooms and connect that sensor to some brain. And that brain would be connected to water inlet. How does it work? That sensor might be simple cable or two-wire cable, or two cables of metal placed in a shell which is that water resistant. So if that product will be subjected to water, it will short circuit, and then controller will know that something had happened and it will close inlet. There are lots of small gadgets around in the market which can be connected to Danfoss solenoid valves. If we're speaking about bigger buildings, probably we will speak about kind of pressure measurement or something, because there are more spaces where you can anticipate something wrong is happening. And what we do observe, a new standards of poor, meaning that there are European Union directives where water intended for consumption should be clean, pure, or meaning that we have impurities which are coming from all the installations which contained more lead. One of the stuff we're using in the solenoid valve business is metal. Actually, it is a brass which contains lead. We have currently three types of lead, not lead, but brass. That's an ordinary brass. Then it's DZR brass, which is more resistant to the corrosion, which is happening in the water pipes. And we have a new metal, which is quite new on the market. It is called Eco Brass, like a trademark by some producer who's producing that brass, where we have lead content of 0.1% or less. In ordinary brass, you can discover something around 3% of lead. And European norms are telling water should be clean. Therefore, different institutions around are advising what should be done, what materials should be certified for water, and there are initiative, or there is an initiative from the 4 member state organization where, as you can see, some countries are listed. They are taking care about promoting ideas how and what should be done in the potable water world. So we would drink water of a good quality and which would be not polluted with different metals. One of them would be probably lead, considered to be one of the mostly dangerous. Directives according which Danfoss is working. Of course, low voltage directive, because we have electricity. Pressure equipment directive, because we have pressure. We have ROHS directive as regards of pollution, we may say so, or materials which shouldn't be widely used in the metal. And of course, on the top of that, we're having great concern about green product, about cleanliness, about just environment, we can say so. And we would like to become a leading company in that business. Stakeholders, meaning who is involved, from consulting engineer communities, wholesalers, all we are in the same sledge, we may say so. Okay, so now we will switch to something terrible, to the lines, to how does it work. Solenoid valve, as you can see, is made of valve body itself, where something is flowing through. It's made of kind of cylinder, which contains armature insert. And yeah, how does it go? How does it work? Solenoid valve should be made so that the coil strength, the coil which is raising armature to push water through, should overcome all these pressures and the conditions which are, yeah, something which are subjecting in opposite direction. Armature closing spring, that's one. Force from differential pressure, that it is. Differential pressure would like to close the valve, because you may say that it's pressure balanced, because differential pressure would like to press down the armature, and on the other hand we have some force here, but yeah. And we have of course gravity of the armature tube itself, or not tube, but armature stuff. So here we go. We need to place a coil. When we're giving currency into it or supplying power, then armature is moved. In this example, it would be opened and water will go through. So simple. What should not be done is to connect electricity to the coil without installing it on the product itself. Now we will go through the main valves we have. These are direct operated, meaning there are no partial or there are no sophisticated solutions in there. You are just supplying power and coil is opening and closing it. These valves are of limited capacity, so not much of water will flow through it. Yeah, and they're limited with the pressures on the larger sizes of the valves. What's good? They can operate from zero difference. I will tell you later on, and you will see what I do mean. Yep. And high pressure and small sizes can be handled. Another guy is direct servo operated valve. You see the names, valve 200 something, and then B, and these are the code names for the Danfoss products. 2 would be for two-way valve, 3 will be for three-way valve, but we won't get into these details. Okay, these guys are of limited size. They might wear a little bit faster because of quite long movement inside. The larger coils are needed to operate them. What's good? Actually, they can operate from almost zero differential pressure. That's important in some systems which we'll analyze, which we'll go through later on. Servo-operated, more complex, and they cannot work from differential pressure zero. I will show you on examples later on. And they have some pros. They can be large. They can be water hammer damped. They can go to quite large pressures. So I will hardly be able to run a macros here. Something had happened to me, so I cannot run this macro. I will explain it on these pictures. When coil is disconnected, valve is closed. After we are supplying power, you see the red color here. It comes, electromagnetic field is built up, and the inside of armature is opened. So water can go, or something can go through, and everything's okay. We are disconnecting power, then armature is dropped. So simple. Valve is closed by a spring. If it would be not normally closed valve, as here you can see, without power, the valve is closed. It's called normally closed. If it would be opposite, if valve would be opened without electricity, it would be called normally opened. Another guy with a servo principle. Valve is closed. What can we see? I guess you can discover the hole in the membrane. Can you? That's a membrane. By moving through it, you will discover one hole. It's closed. It should be. It's closed by armature, but what do we see here? Why do we have a hole in membrane? That shouldn't be a case. Actually, the valve is closed. Why and how? Pressure in front of the valve is built here. And even if it is zero differential pressure here, the valve will remain closed. How it is opening then? It's opening in this way that armature is risen from the tiny tube where pressure is going away from the valve, out from it, and gradually a membrane is opening the valve because it's just rising. So we have open valve, everything is fine, and now we are disconnecting electricity, for example, and we are closing that small channel. Pressure is starting to build on the top of the membrane, little bit by little bit, and valve is closed. So I had mentioned that it had a rather large stroke, as you can see from this picture, and from this picture it is moving quite much, so that might be considered as maybe weakness, but this principle allows us to work with zero differential pressure when valve is closed. Well, the third principle is about servo-operated valve. How does it work? It has a tiny channel across the valve itself. When it is closed, armature is closing a channel. No flow through the valve. Valve is closed by the spring and partly by the pressure upstairs. When we are supplying electricity to a coil, water starts to evacuate from the membrane, from the space above membrane, and valve is starting to open. You see, membrane is bending upwards, and it is opening. Only a pity the drawings are not showing us. Anyway, water can go through. So part of the water is going through the main channel, and small part of water is going through the bypass. When we are closing the valve by disconnecting electricity, membrane starts to bend out because water is not flowing away, so we have a buildup of the pressure, and plus spring is helping us here, so valve is closed again. Therefore, these valves need minimum difference. So if you will use a solenoid valve somewhere, one of the questions should be solved immediately is, do you have differential pressure? I will show something in the pictures later on. Another topic which might help you is to discover and understand which valves you should use in your application, because one of the applications will be water, another one will be air and natural gases, oil, slightly and more aggressive media steam. So you can see these symbols which are in the data sheet or in the catalog. Allows you to identify which one should be used. For example, 225B, small letters, is used for the steam. So we don't use it anywhere else. 250, we might use quite widely. And you see these strange arrows, squares, they do tell you about what systems it can be in. Open system, just an arrow. Open system would be tap of the water where you're washing your hands. When you're closing it, you have water pressure somewhere in the pipes, and you have almost zero pressure in front of the valve. So that is open system. Something closed as a heating system, where you are just circulating round and round and round water. That is closed system. And another line and another line, and on the bottom you can discover the sealings which we are using. Some materials are okay for the water, like EPDM. We selected that principle to be used in the domestic hot water and cold water. And FKM would be used in something slightly aggressive, something here. For the oil, you cannot use EPDM. For the air and gases, you should use again FKM, because if you would use EPDM with the air, you might discover some issues because of the oil which might be present in the air. So this overview just tells you which model you can use, and later on you have to double check it more properly. One of the topics is about designing of a new buildings, where there is a rule of thumb that sanitary premises should be disconnected or protected from the water leaks. And how do they do it? They are using PIRS, presence indication sensors, which under the detection of the person entering into the room, or they are opening, and if that person is away, they're disconnecting water by just opening, closing these valves. If person is away, person equals 0, valve close, valve close, valve close. Quite simple. In heating applications, we do use solenoid valves in the feed water. When our heating system pressure is falling from the desired value, electronic controller ECL is switching on valve, switching on pump if needed, and then we are filling it up for a period of the time we need to fill it up. If we need to fill it up some 10 liters, here we go. Quite simple. That's a chart from heating system. How does it go? You see something in February had happened, that within a day, when the system was filled up, pressure started to gradually go out. So then again, it was fixed, and etc., etc., etc. So that's an example of something wrong is happening, and then somebody should take an action to solve it. If it would be one day, then the chart would be smoother, because now Yeah, it looks like odd. Pictures we are showing. I promised to tell you something about open-close system, so here you go. Closed system is a heating system. Here you have a drawing of a solenoid valve where you see a coil, a valve, and in the closed systems we use one kind of product. In the open system we use different ones. That's another valve. And here you have to consider how high the horizon of water is from the drain. If your valve is operating well with a difference of 0.3 bar, mean that this water column should be minimum 0.3 and larger. Otherwise, you will get drops, or even it won't close anyway. We had an example where road building company desired to purchase solenoid valve from the wholesaler, and they installed this large DN40 valve on the truck with a water tank of several cubic meters of water, and the complaint came that, hey, the valve is not closing. Then we had to explain to them that, guys, your water drain valve is just less than 1 meter from the water tank's bottom, and it should have minimum 3-meter water column to close it. It was an issue. So if you will install that kind of valve in a cold water system, hot water system, everything is okay because you have large pressure here. Yes, you will have tap down after this valve, but then everything would be fine. Spring will close, everything's okay. Yep. Open systems, yep. But just explain you a little bit about it on the example of a closed. Yeah. And sensitive to dirt, long lifetime. So in some data sheets we were presenting that item is having medium or high or low resistance to the dirt. Durability is working longer or shorter. It depends on, are you switching your solenoid valve once per day, or are you using the solenoid valve in the brewery where you are filling bottles? Again, if you're using it in the heating system where you have to fill up your water just maybe a few times per year. Water hammer solenoid valves are working quite fast when powered, so it might be that some of them might raise hydraulic noise or hydraulic blow hammer. So we can play around in the solenoid valve to reduce that phenomenon. How do we choose solenoid valves? I'm moving around with my video, which I see on the screen and which is helping me to, yeah. Okay, so maximum differential pressure should be considered. Flow capacity, you calculate kV value and you determine valve size. Medium temperature, it should be in the range of specification, otherwise valve can just be destroyed or rubber can just lose flexibility. Ambient temperature solenoid valve should be in kind of situations where it is not overheating. Yes, you can hear a claim of your customer that my coil on the solenoid valve is hot. What should you do? Yeah, if you're powering it and if a solenoid valve needs some 3, 5, or maybe 10 watts, then it's heating. Impurities. Yeah, it's a good idea to have a filter. If there is a risk of a hammer, for example, straight long pipeline, which if stopped can really develop a water hammer. Material choice, as was said. Don't use something what hates oil. If your customer tells you I need a solenoid valve for ear application, then you should consider specific material because ear can contain oil, and with the time, solenoid valve will be jamming, or it may fail at all. For aggressive media, stainless steel or DZR brass is available. And we have a checklist sheet where it's relevant to tick out what is inside, then really we will have a good solution. As for the KVS, we have a flow, we have a density, we have a delta P across a valve, and here we go with a KV value. Coils are different. We are using normally clip-on, so you just put them on the valve and you press and then it clicks. Here we go. Connections of the cables might be different. Either plug, either, as you can see, socket, either socket with a cable. There are some coils which can be screwed on, which can be explosion proof. Here you go. Different adapters. For example, the one quite often called Hirschman connector. There's another guy which have a LED inside or light emitting diode. So when you're powering it, then you see a light that solenoid valve is powered. Might be useful. And yeah, some other connection boxes. Now we are going through the program AV220, from 6 to 22 millimeters. Of course, connections will be different, but it's good general use. Solenoid valve might be from few metals. Yep. And is dedicated for open systems, not for the closed. These two are closed. Medium sensitivity to impurity, long working. Yeah, but might maybe do something with the hydraulic blows. Steam valve 225B. It's not new version. Yeah, it's already in the business. It has some few different temperatures because of few different pressures. 220B, the one we are using most. Again, for the open systems. It's available in different metals. The larger one from 65 to 100, made from cast iron. And now we are switching to something what relates especially to drinking water. A few solenoids, small, medium, and one which is having specific feature of a latching. 228 is something different. We were now talking just about solenoid valves where you are applying currency, but that one is quite tricky. We will tell about it soon. Yeah, 221 BY, you can see W standing for water. So it's up to 1 inch. Immediate temperatures up to 90 degrees. Pressure differences, normally closed open. EPDM, lead 3 eco brass. I was just telling you before that this brass is specific and it's approved for the water usage in Nordic countries. And it's approved because it has almost no lead. It's 0.1% or something like that. So it's really pure valve. 220B, that's a working hose, the N1550. Yeah, but you have to consider that, yes, I am demanding something. Yeah. And the last guy, 228B, it is using latching feature. I will explain it, how does it goes. That's a brief list of code numbers. And as you can see, the 220 BW is up to DN25 in eco brass because we do not receive parts or raw materials to prefabricated larger sizes. Stainless steel is available from DN15 to DN50. Now we expect that market will deliver raw materials and we will be able to close the gap of valves with that special metal. Coils, 24 volts. When wholesaler is asking Danfoss for the quote, they normally say, I need something 24 volt. Please consider telling it, is it AC or is it DC? Yep. Normally these coils or BB coils or blue coils, or they are of IP0 because cable plug is not installed. When cable plug is installed, then we have a larger IP class. How do valves and coils operate if we are speaking about latching feature? That's when you are powering your coil with DC voltage with plus and minus, valve is taking one status. For example, it's closing. And when you twist, when you turn your electricity upside, not up, yeah, when you're twisting it or changing it, then the valve is changing to another status. What's good in that? Imagine you are using solenoid valve, which needs to be powered to keep the status, for example, closed. If the coil is subjected to electricity and water is not flowing through, then this very place is becoming hot. So with the latching, you are just twisting and you are not investing so much in energy, we may say so. Our top product, yep, explain in details. Yeah, we have a huge experience on creating them. We have a very specific construction of it. We have even built-in filter to protect that channel across. We have this pressure stabilization or anti-hammer screw where we can change the opening and closing of a valve a little bit. Yes, we have eco brass. We have square amateur tube design. So insert, which is flying up and down here, is kind of a squared on the corners. So it's self-cleaning better. Yep, benefits. There are two alternatives on delivering or selling these items. Valve, coil, plug separately, either everything assembled from the manufacturer. So in this case, you will have just one code number. Yeah, DN something, voltage something plus plug, and here you go. On the other hand, if you would like to be flexible supplier, you would then choose to stock different size solenoid valves, several coils, which are used commonly, and plugs. So yeah, when you need a replacement of a coil, you are just buying coil. When you need just valve, you're buying just valve, and you can create a lot of constructions depending on how many sizes you have, how many different coils you have. You can build it up. Sorry. How to identify a valve before? We had labels, plates sticking around, but with the time, these markings are disappearing. So now we have a hidden treasure on the on the coil, not on the coil, but on the armature tube. We have data stated, written, what's a product in there, type, when it's made, and etc. So if your customer would like to replace a solenoid valve, just ask him to make a clear picture of what's on the coil, because that technique is already quite a while on the market. Coils, yep, that's quite simple, straightforward. Recommendations for installation. Install a filter in front of it, and maybe consider check valve or non-return valve after it if you're using it for domestic hot water, because when your hot water is heated, then probably water will try to go out. So it might be that the solenoid valve can be, in some cases, opened from the reverse flow. Consider making exercises daily for solenoid valve so it won't stuck. And some water features like hardness, conductivity. We know that if conductivity is rather low, then water tends to be aggressive and to attack brass, to wash copper, to wash zinc away. Yeah. Recommendations for the installation. That's again, if something fails, one of the first things is just to look how product is installed, because some designs are taking consideration into gravity of armature inside, so they shouldn't be twisted far too much. As you can see, different names, different angles. Some consider large angle, some little. You can download an app which you can use to discover a solenoid working or not. So that circle will start turning. I used this app for the pumps. Some pumps to also indicate that there is an electromagnetical field and everything is going okay. Some pumps might be difficult and they would not like to twist this guy because of something is different. Yeah, but electromagnetic or magnetic tool really detects magnetic field and that circle is twisting. Applications from the market, from Lithuania, from our office. I was going through somewhere downstairs and discovered that that's K like hot water. So we have a meter with M-bus, pressure reducer, and solenoid valve. And these solutions are used now in water systems just to connect them and control. That is another topic from the heating system, just to fill up, make water. Oh, of course, it's simply with pressure switch. Yep. So, and now I have a small stuff. I have a poll, which I would like to start now. I would like you to read and answer question by question. I will give you some time. I'm launching first poll, so I hope you can see. I'm asking if consumers using washing machine, which solenoid valve should be used? Open without electricity, closed without electricity. What do you think? Not all voted. Time is running. Yeah, thank you. I know. Should I also vote or not? Can I improve something? Haha. I see that 86% voted. Maybe some didn't. How can I know? Okay, maybe I will go now to different poll. I will close this poll and I will switch to another. Yep, another poll. Water in a tank horizont is 2 meters up from the drain valve. Should any kind of solenoid valve just offer it without taking no consideration, or should we mess around that? Maybe we need to sell something different. 40% voted, 60. I guess I will be able to share vote results with you. Somebody needs to think. Just, yeah, 70% voted. Yeah. Oh, hell. What is answering the same stuff? What could it happen? Yeah, good. Yes, I needed that answer. Okay, so I guess that everybody voted who desired, and I will switch to the third question. Yep. European norms about potable water, considering reduction of lead content in a breast because lead starts to be expensive, or because somebody would like to reduce quantity of lead in water and maybe, I don't know, maybe save lead for something different. I know that fishermen can start discovering themselves without some tools for fishing. Yep. 71% voted, so one or two did not yet push the button. Please, the one who did not press the button, press it. Or he had or she had left. Yes, seems I collected all. I will try to close it and I will try to hear the results. How should I do it? I'm looking. Should I share one by one? I'm sharing first result. Hope you can see that 17 told that open without electricity, 83 closed without electricity. I will try to share another one. That's about any solenoid valve should be offered. 17% at 83, that minimal pressure should be considered. Okay, and the last one. Lead. So lead is not becoming more expensive. Somebody's concerned about water quality. Okay, so thank you for answering polls. And I guess I'm sharing a screen now. Maybe questions are available. So shoot, carry on. No questions. Yeah. Okay, if really no questions, I would thank you all for attending our webinar. This webinar would be available on the internet and you will be able to watch again, remember something, maybe. That will be fine. So thank you very much and goodbye.
Thank you.
Thank you.